Native Computing Foundation, Dan Kahn.
Where do you go? Are you looking for answers to questions?
Good
All
morning,
right, guys,
San
here we go.
Diego.
If along the way.
Good morning.
The Cloud Native Computing Foundation is the organization that hosts these open source projects and organizes this event. We also published the Cloud Native definition. Quote, one of CNCF's goals is to democratize state-of-the-art patterns to make innovations accessible for everyone. In order to share with you a short parable about this democratization, I need to introduce my family. We live in New York City. We'll get there. Where my wife, Julie, is a climate scientist. She couldn't be here this week, but her climate change forecasting startup, Jupiter Intelligence, uses Kubernetes.
Of course she does.
This is our younger son, Ellis, who's 10, and throws a solid fastball. And our older son, Adam, just became a teenager. And this is our cat, Koros. When Adam was a 7-year-old second grader, a bunch of his friends started playing Minecraft. So I installed it on his iPad, and a week later, I found Adam sitting on the couch, but with an iPad screen instead of books, and no little brother, and with a frightened expression like this. But the strange part was that his iPad screen was black. Why are you staring at a black screen? I asked. I'm hiding from the zombies, he replied. I don't see any zombies, I said.
Oh, man.
The zombies come out when the sun sets, he explained. The screen is black, he said, because I'm hiding in a hole in a hill. You see, Minecraft might look like this during the day, but at night, the zombies come out, and my second grader had not yet learned any of the ways that he might defeat zombies. But he had figured out that he could dig a hole with his hands and close it in around himself until the screen went black. This story is a metaphor. The second grader represents most enterprises.
Yes!
Although Kubernetes crossed the chasm last year, the majority of all enterprises are still not cloud native.
Does this sound familiar, guys?
Represent software failures, specifically anything that can cause downtime. Hiding in a
Zombie
hole represents
apocalypse.
precautionary software practices, such as long release cycles, infrequent dependency updates, and manual quality assurance.
Yep.
I want to emphasize that for both second graders and for most enterprises, they are not acting irrationally. The zombies are real. Precautionary practices are a reasonable response. I also want to make clear that in comparing enterprises to second graders, I'm not exempting my own organization. CNCF is part of the Linux Foundation. We host software including Linux, Node.js, and Let's Encrypt. And yet projects we've undertaken, like an open source CLA bot, have been delayed. The solution for my second grader, Adam, was to arrange for the older sibling of a classmate to come over, a fourth grader. And the fourth grader taught us about crafting tables. You know how when you combine software development with information technology operations, you get DevOps? Well, similarly, Minecraft consists of mining and crafting. And my second grader had figured out how to mine all on his own, or at least how to dig with his arms. But he didn't know how to craft. And crafting is critical to the whole game.
I think I see
Let's
where
take
this
a
is
look
going.
at a simple crafting example. Take a pumpkin, some sugar, and an egg, and use your crafting table to combine them together into a pumpkin pie. Yummy, but not so useful. So let's do a more complex example that will help us stop zombies. Chop a tree to get wood, which you form into wood planks and then use to make a stick. Kill a spider using a bow and arrow to get some string. Now dig in gravel to find flint and kill a chicken to get a feather. And finally, combine these all using a crafting table to create a bow and some arrows, as long as you ignore the circular dependency error. The lesson of Minecraft is that you can take simple things and combine them together into much more powerful, complex things to build very powerful tools. And here at KubeCon Cloud Native Con, we're doing the same thing. As you probably know, Kubernetes uses the firewall technology IP tables to manage networking connections between pods. IP tables depends, of course, on Linux, and specifically the networking subsystem. The first Linux firewall, IPFW, originated from BSD. It was soon replaced with IPFW ADM, the Internet Protocol Firewall Administrator, which was more complete and easier to use. This was re-implemented as IP chains, which was superseded by IP tables as part of the NetFilter system. It is now being re-implemented using eBPF, the Extended Berkeley Packet Filter, which has an awesome logo. So, firewalls are a core building block of Kubernetes that have been crafted into more advanced forms over time. But so are C groups and the domain name system and the RAF distributed consensus algorithm implemented in etcd. In fact, Kubernetes is built on hundreds of foundational technologies that have been combined together. But I would go a step further and argue that Kubernetes itself is like a crafting table. It is a kind of alchemy that turns simpler things into more powerful ones. Kubernetes, in short, is like Minecraft. You have all the tools you need to build what you want, and even tools to build new tools. But what we construct is up to us. Finally, where do the fourth graders and the second graders come together to share their crafting formulas? The answer is KubeCon.
GitHub. No, KubeCon.
Please raise your hand now if this is the first KubeCon you've ever attended. Yeah, absolutely. You are the metaphorical second graders. And what's the benefit for the fourth graders? There are two. First, after we got educated about crafting, my son Adam gave the fourth grader a cookie. No, I mean a cookie. The metaphorical fourth graders in the audience who can provide assistance to those second graders may find that they are showered with cookies and, job offers. And the second, and even more important reason, is that the second graders will soon enough become fourth graders.
Yeah.
And our community, where democratization is a core value, is eagerly looking for people who can contribute new and improved crafting ideas. Kubernetes is only 5 years old, which means that we are all still in elementary school. I look forward to seeing what we will learn from each other. Thank you very much.
Nicely done. Technical difficulties with the slides and the clicker.
Please welcome KubeCon and Cloud Native Con co-chair and engineering manager at Lyft, Vicky Chung.
Oh god, that's loud.
Have you heard the news? Everyone's talking. Life is good because everything's awesome. Lost my job. It's a new opportunity.
Hi, good morning. Our next presenter is Cheryl Hung. Cheryl is the Director of Ecosystem at the Cloud Native Computing Foundation. Today, she'll give us some updates on CNCF. Please welcome Cheryl Hung.
똑같은 생각에 틀에 박혀 있네. 왜 더 가지 못해? 바로 눈앞에 있네.
Good morning, and welcome to KubeCon Cloud Native Con. It's amazing to see 8,000 people in this room, plus many more who are joining us on live stream. So welcome to each and every one of you.
Thank you.
So I'm Cheryl Hung. I'm the Director of Ecosystem.
Hi, Cheryl.
And at the CNCF, I work to get end users active and engaged with the community. So I really appreciate how hard it is to build cloud-native systems, because this is what I did when I was a software engineer at Google. Just after I joined the Google Maps team, I was adding some C++ code, and I accidentally dereferenced a null pointer, and I took down every single service globally from my team. So I think on that day, I learned why we put so much effort and time into building these systems. So in addition to the 129 end-user members, CNCF is made up of more than 500 member companies, and they support the work of the open source community. So for instance, AWS has donated $200,000 of cloud credits that will go to CNCF project maintainers to help with performance testing, CI/CD, and storage.
That's fantastic.
More than 100 companies have certified that their Kubernetes offerings are interoperable with each other, which gives end users more flexibility and more choice. So we have some new CNCF members now.
Yay.
ARM, NetApp, and Palo Alto Networks are our newest platinum members, and Equinix and Fidelity at gold. So I'd like to welcome some of our speakers on stage now to talk about why cloud native is important for them and their organizations, and why they're excited to get more engaged with the community. So first up, please welcome Kevin Ryan, Senior Director of Software Ecosystem at ARM.
Thanks, Cheryl. Hello, KubeCon. Wow, this is a great big audience. This is fantastic. We're really happy to be here this year with a large amount of the ARM ecosystem that's here with us. And we're most excited to announce our increased
I feel like I know that guy from somewhere.
With the community this
I've
year.
met him.
So that's a big thing for us.
It wasn't with ARM, though.
Now, if you look at ARM, why are we here? ARM is really focused on this journey of enabling 1 trillion devices and building out that infrastructure to enable those 1 trillion devices. On that journey so far, there's over 150 billion chips to date. So we're well along our way on this journey to enable this infrastructure and all these devices at the edge of the network. The
That's
reason
a lot of chips.
we're here in increasing our investment in
billion.
the cloud native community is we believe the way to build out that infrastructure is with this community, and to work closely with the cloud native community to enable the delivery of services from the largest hyperscalers all the way out to the smallest device in the network. So we really look forward to working with this community in the coming years to continue to innovate and make sure ARM is a first-class architecture for all we do in the CNCF. So thanks, Cheryl.
Thank you.
Yeah, it's an interesting perspective to have if you, outside of enterprise IT, I think most of the data that's going to get generated over the next 10 years is going to come from
Director, Cloud Native
devices,
and Kubernetes
smart
engineering
homes,
at NetApp.
manufacturing, IoT,
Hey,
all of that. Hey, Matt Baldwin.
there's a lot of people here. I was at the first one. It was not this many people. So I'm excited to be here to announce that NetApp has upgraded its membership to Platinum with the CNCF. NetApp's actually been involved with the cloud native and Kubernetes community since the beginning, engaging with special interest groups such as SIG Storage and now SIG Cluster Lifecycle. NetApp was also a founding member of the CNCF at that time. And then last year they acquired my company, StackPoint Cloud, where we had also built some of the largest cloud native and Kubernetes communities in the United States with membership exceeding 15,000 people. Ariel and I actually built those communities to help evangelize and promote Kubernetes at a time when it was unpopular to do so. And now as CNCF ambassadors, we continue to do that in all the local locations that we do, that we run. Looking forward, we're excited to engage with the CNCF. We're excited to engage with the community. We're trying to make cloud native applications easier to run on Kubernetes.
Oh, poor
With
Matt,
that, thank
he's
you.
so
Have a good
nervous.
KubeCon.
Thank you.
Oh. Good job, buddy. Good job.
Okay, next up from Palo Alto Networks, please welcome John Morello, VP Product.
Hey, thanks everybody. I'm John Morello. I'm VP Product at Palo Alto Networks. You may know me from my previous life. I was the CTO at Twistlock. So proud to have many of you guys as customers and hopefully now customers of us as part of the Prisma product line at Palo Alto. At Twistlock, we were one of the founding members of CNCF, and it's really pretty amazing to have seen all the early KubeCons and see how relatively small and much more sparse that these keynote sessions were, to see what it's grown into. The reason why we're so dedicated to this and why we're investing in becoming platinum members now is we really feel like CNCF is helping shape really the 6th generation of computing. Certainly a major change from what you've seen in previous generations, from client server to virtualization and cloud and now cloud native. And all of the innovation, all of the guidance and how these projects are being built and how they're going to shape the world is really being driven through CNCF. So we're really proud to be part of it and proud to continue contributing to the community.
Awesome. Thank you. Okay, and last but not least, we have our newest Gold end user member. So please welcome Joe Frazier, Head of Enterprise Cloud Computing at Fidelity.
Thank you, Cheryl, and thank you, CNCF, for welcoming us into this awesome community. Fidelity has a long history of product and technology innovation that we are very proud of. However, as we say with investing, past performance is no guarantee of future results. Like many in our industry, we are facing an ever-evolving competitive landscape. For us, cloud-native computing and the open source ecosystem will be key enablers of our digital transformation. We are pursuing a multi-cloud strategy, and Kubernetes and the CNCF ecosystem are at the cornerstone of that strategy.
Yep.
We have learned a great deal through the challenges adopting cloud computing in a highly regulated industry. We have tools and capabilities we hope to contribute back to this community and a wealth of benefits that we will gain from this partnership. I'm incredibly excited for Fidelity to join CNCF, and I look forward to taking this journey together. Thank you.
Awesome customers, Fidelity. Love working with those guys.
Thank you, Joe, and thank you to all of our speakers.
One of the more ahead of their time kind of customers that
the future
are ahead of where the rest of the enterprise
is going. We've just launched a new Cloud Native jobs board, so you can check out all the companies that are hiring for Kubernetes
now that's awesome.
and Cloud Native expertise, and this includes lots of jobs that are working remotely.
Look at all of them in Boston.
Finally,
and New York.
CNCF is supporting new community-run conferences called Kubernetes Community Days. And I'm particularly excited by this because meetup organizing is how I got into open source. So when I was a developer advocate at StorageOS, I was looking for places to speak. And I looked, there was a Cloud Native Paris and a Cloud Native Berlin, and there was no Cloud Native London. So I created it to see if anybody would show up. And from there till now, I really enjoy seeing 200 to 300 people every single month coming to our meetups. And I'm actually organizing the Kubernetes Community Days for London. So if you want to bring KubeCon, Cloud Native Con, home with you, please do. You can sign up at kubernetescommunitydays.org. With that, these slides are on my blog at oishel.com. Thank you so much. Have a fantastic KubeCon.
All right, so let's follow her because I was not aware of her. Cheryl Hung, Director of Ecosystem at Cloud Native Foundation. Nice to meet you, Cheryl.
Thank you, Cheryl. Our next presenter is Brian Lyles. Brian is a senior staff engineer at VMware and my fellow co-chair for this event. Today, he'll be sharing with us some Cloud Native Computing Foundation project updates. Please welcome Brian Lyles.
go, Brian.
All right.
All right now.
So the greatest trick the devil ever proved was playing some Dead Prez at KubeCon on the main stage. So you're welcome. All right, so today I'm here to talk about CNCF project updates. And this is really hard for me because there's a lot of CNCF projects. But what I like to do is bring up some projects that I don't feel that we are talking about enough, and then also bring up some creators and maintainers and people who are associated with projects so they can actually take advantage of this stage to share the enthusiasm that they have about their projects.
Smart.
So I have 3 of those today, but let's get started off with one project that I just don't think we talk about enough. Core DNS. And the reason that this is first is because I believe back in January when Core DNS graduated or moved to graduation status, we didn't have enough fanfare. Because one thing that I would like to say is that way back in March of 2017, Core DNS is one of the first sandbox projects. So it actually moved from sandbox to incubation to graduated, which means, guess what? The process kind of works. But the reason I like Core OS is because of what I put on this slide. It's all about simplicity. You get simple DNS. And for those of us who actually have configured things that rhyme with rind in the past, we can all appreciate the value of not only a simple configuration, but a pluggable and a modular configuration. So I invite everyone to go check out Core DNS and see what they have to offer. So next up, I want to bring Vitess to the stage. And what I have is, I have Sugu. I always say his name wrong. I'm just going to go to the next slide. I have Sugu here, and he's going to actually give us a couple minutes about Vitess. I'm going to sit here in the corner.
All right. Thank you, Brian. All right. First order of business is Vitess has graduated.
Hey.
For me, it's more like colon sweat smile, you know? So about this graduation process, the main difference is that they use a bigger lens. They want you to overkill on every one of these categories. Like, for example, if it is adoption, they want to make sure that we have mission-critical production workloads running in real companies. You know? And when it comes to maintainer diversity, they want to see prolonged contributions from multiple organizations. And then after that, they drill down into the details of the project, ask about how are you doing your testing, what are you doing for your design strategy. So they make sure that the project is actually healthy from inside all the way out. So having gone through this whole scrutiny and coming out successful is super exciting. So what is Vitess? The simplest way to describe it is a cloud-native database. That means that it can run in an environment like Kubernetes without losing your data. Important.
Okay.
It can scale massively.
Tell me more.
And I'll talk about that. Highly available, like 5 nines of availability is pretty comfortable for a system like Vitess. And it's based on MySQL, which means that if you're on MySQL, it's pretty easy to move to Vitess. So I'm going to talk about a few case studies where how Vitess is used out in the wild. The first one is Slack. So as you must know, Slack is experiencing hypergrowth. This is a graph from them. And, but that's not their only issue. Their issue is also very fast-changing business needs. And they needed a system that is flexible enough to accommodate those changes. So, and they were debating between a build versus buy decision. And they found the best of both worlds with Vitess, because they could buy into Vitess, but also build features that it was lacking that they needed. So they are now about 35% migrated, and they are shooting for 100% around next year. And this statement from Slack basically is a testimony to how much they love Vitess and how trusted it is. So that's a good stamp of approval. So JD.com is one of the largest online retailers of China. They use Vitess. So they recently had their Singles Day sale, which was last week. It's their Black Friday of China. So I want you to think about what kind of QPS Vitess served for them, peak QPS, on that day. And I'll reveal that number in a moment. So they have a pretty large instance. They have about 4,000 Vitess key spaces, and that amounts to about over 30,000 pods. By the way, they are one of the largest Kubernetes deployments in the world. So, and their QPS on Singles Day is 35 million QPS. So you could call that massive scale. And in case you find me in the hallway, you can tell me what number you guessed later. So in contrast, Nozzle is a startup. So why would a startup want to use something like Vitess, which is built for massive scale? So in my opinion, they are one of the best role models of what startup companies should be doing these days, which is to run all in Kubernetes. So in their case, their software runs on all Kubernetes, and they got a really good deal from Azure. So they deployed their software on AKS. So after a while, Google Cloud countered them. They had a better deal. So what did they do? They just packed their bags and moved. So that is the advantage of running all in Kubernetes. There is no vendor lock-in. So my parting thought with you is, if you are moving to Kubernetes, don't leave your data behind.
I wouldn't say there's no vendor lock-in.
And if you ask me, the best way, like in the future, I think people that host services should run their services on my Kubernetes, not like me running Kubernetes and calling out into their services. So there are some exciting talks coming up. One of the best is, I would say, attend the one from Slack, which is at 11:50.
I would love to see that.
They know a thing or two about running resilient systems, so definitely highly recommended. If you want to know how to make a storage system or a database cloud native, you can attend my talk at 3:20, and you can hear from the horse's mouth about how Nozzle did all these tricks with Vitess and how they benefit from it. It's been great talking to you. So the best way to find me, in case you want to talk to me, is to come to the PlanetScale booth. Even if I'm not there, somebody will know how to get hold of me. Thank you very much.
Thank you, Sugu. So Vitess, we'll put that one on the list to check out on a future Friday afternoon stream.
I want to apologize to Sugu.
Definitely want to look into that.
Actually, I can say his name, but lights and cameras. So thank you, Sugu, and don't send me any hate email later. All right, so next up, I want to talk about another project that is actually in our incubator right now. It's Linkerd. What Linkerd is this thing called a service mesh.
Yeah.
And I'm not going to go into what a service mesh is, and they have generously created this really amazing slide. But I actually want to highlight a few things. Is this 2.7 release that is getting ready to head up, mutual TLS for all TCP traffic. Encryption is good. And the next item here is mandatory TLS. Think about this. Having encryption available is neat, but making it so that it has to be used so your developers can actually think about your development instead of security all the time is even better. And the next thing I want to share here is a little bit of a video that Linkerd shared with me with an update. So this is a Canary rollout. And I was told not to annotate this all too much, but because they wanted to show the power of what a Canary rollout would look like in Linkerd. And you'll notice that there's not a lot of operations going on here. So what we're seeing right now is Canary traffic, and seeing that there wasn't a lot of configuration that needed to happen to configure canaries. The second piece was
I have no idea what I was looking at, really.
Has,
it was so fast.
Access where they are doing observability and trace metrics with Jaeger. So what we're going to see here is that Linkerd will create all these tracing spans for you, and you do not have to create them yourself, so you can actually see more of what's going on in your application. All right. So next up, I want to talk about a project called Helm. And to talk about Helm today, will be Matt Farina. So welcome, Matt.
I thought you were about to say Matt Baldwin. We love Helm. We're all in on Helm at NetApp for NetApp Kubernetes service.
Thank
love
you,
it, love
Brian.
it.
For those of you unfamiliar with Helm, it provides package management for Kubernetes. You can think of it as the apt yum or homebrew for Kubernetes. Helm has taken a rather unique path to find its current home in the CNCF. When the CNCF launched and Kubernetes joined as the first project, Helm was a sub-project of Kubernetes and came along with it. Last year, Helm had grown to the point it could become its own CNCF project, and it did. At that time, Helm had more than 50,000 downloads a month.
A month?
I'm happy to share that Helm has now hit a point where we've had over 1 million downloads in a month's time. The downloads include binaries for Windows, Linux, and Mac, and we're seeing an increasingly global distribution of those downloads.
Holy smokes.
According to DevStats, the CNCF's analytics tool, in the past year, thousands have contributed to the Helm client and the other Helm projects. We've also had a growing number of maintainers and an increasing company diversity among them. Can I get a round of applause for the Helm contributors? Without them, the Helm project wouldn't be what it is.
Good job, contributors.
The number of contributors in the past year is about the same as the number of contributors in the total time from when Helm started to it becoming a CNCF project. Now I'd like to talk about something big that happened last week. We released Helm version 3.
Yay. Goodbye, Tiller.
This is a major change based on feedback from the community and changes in Kubernetes since Helm 2 was released. These changes include the removal of Tiller.
Bye.
For those of you who don't know, Tiller was the server portion that typically ran in a Kubernetes cluster. Charts can now include a JSON schema describing the values. Helm will validate against it. And Helm supports library charts. These charts can contain reusable components and can be imported by other charts. If you're familiar with Helm 2 and want to learn about the changes in Helm 3, you might want to check out the Helm 3 deep dive tomorrow. As part of the process to release Helm 3 and work on CNCF graduation, Helm 3 went through a security audit. A security audit is a requirement for graduation, and the CNCF funds them. They help projects improve on their security, and those of you who are users of the projects better understand the project.
Highly mature.
What you see
That's
on
what
the
you're
screen
looking for
is an
there.
excerpt from the summary. You can learn more about the audit and read the full report in detail at the Helm blog on helm.sh.
So if you've got Cure 53 saying recommend it for public
We understand
deployment,
that it takes time to transition.
2 thumbs up.
We are entering the holiday season with all the holiday shopping. And right after that is actually tax season. And we know that it takes some time to change from one major version to another. And so we will have a full year support for Helm 2. It's not going away. The first 6 months, we'll have security fix and bug fix. Helm 2 has already stopped taking on new features. And then the following 6 months, we'll just have security fix coverage before it is finally turned down. And with that, that's Helm. Back to you, Brian.
All right, so I would just like the Helm project to know that I was like 4 of those 1 million downloads. So I want to share in a little bit in your success. All right, so moving on, another project that has moved to graduated status recently is Jaeger. And the reason, and yeah, you can be excited. Jaeger's pretty interesting. Yes, give it up for him. The reason I wanted to bring Jaeger up today is because years back, I've been following open tracing ever since the paper came out of Google, and then just following it along. And then one day, Uber, of all people, created this thing called Jaeger. And I'm like, all right. So, but I sat down and used it and realized very quickly that, first of all, that configuring and actually viewing your metrics did not have to be painful. And the one thing that I want to bring up today is that our tracing world is not staying static. And before we talked about, we highlighted that OpenTelemetry is going to be a thing, and they will actually be on the stage talking about that later on this week. But Jaeger is moving along with the open tracing, open census move to OpenTelemetry. So it's good to know that we see that these projects are continuing to evolve around each other. Everyone, they all have their own gravity, and it's kind of like a binary or a tertiary or a quaternary or whatever a fifth area is of projects rotating around each other. And that's really important to the community because as we talk about all these projects on the stage today, we realize that none of them exist in an island, and we're all rotating around the other ones. So for my third project that I would like to bring on today is I'm going to bring up Open Policy Agent. So Torrin, come up and tell the world about Open Policy Agent.
Yeah, actually tell us about it and tell us what it is.
All right, hi everybody.
Because I don't know this one either.
I'm one of the co-creators of the Open Policy Agent, and I'm an engineer at Styra. Now, the reason that I love to work on the Open Policy Agent is because policy and authorization are these fundamental problems that exist in the critical path of pretty much all the software we use. So whether you're talking about Kubernetes or microservices or CI/CD or databases or even Linux servers, policy is everywhere. But the problem is that in the past, policy has been very fragmented, right? Every single one of these projects or products has its own way of letting you express policy. And the problem with that fragmentation is that it makes it really difficult for you to gain any kind of unified control or visibility, or even to just understand the rules that should be
governing. It's a problem with any enterprise software,
behaves.
really.
And so I think that policy
There's so many different
requires
masters
a
of the desired state
and so
and the
that's why
policy.
we started the Open Policy Agent project. So the Open Policy Agent, or OPA, as we like to call it, is basically a tool. It's a building block that you can use to unify policy enforcement across a wide range of technology in your stack. And so today, OPA is integrated with over 20 projects in the cloud-native ecosystem. And this is why we can really call OPA a piece of general-purpose technology, because it helps you kind of break down these policy implementation silos and avoid reinventing the wheel.
Oh, I like that.
So what is OPA? It's a general-purpose policy engine. And what that means is that you can use it, you use it to decouple policy decision-making from policy enforcement. So the decision-making happens inside of OPA based on the policies and the data that you've distributed to it. And the enforcement stays in your software. It stays in your services. So when your service needs to make a decision, it can query OPA, and OPA will crunch the policies and send back a decision to be enforced. So when you use OPA, what you're doing is you're offloading decision-making to a dedicated engine. Now, to make all of that happen, we give you a high-level declarative language to express policy in, and we call that language rego. Rego is actually the Latin verb to rule. And so we thought that was a good name for a policy language, but then we found out way after the fact that it actually means car registration in Australia. So that was a bit of a mistake, but we have to live with it. So when it comes to actually using OPA, you kind of have different options. You can use it as a library, you can use it as a daemon. But the way that we think of it is that it's basically a host local cache for decision making. So we recommend that you take OPA and you run it as close to your software as possible, ideally on the same machine.
Yeah.
Now, obviously, if you have all these OPAs running around in your infrastructure, you need some way to manage them. And so OPA exposes APIs to do things like distribute policies and collect decision logs for auditing, and so on. And then, of course, OPA embodies this idea of policy as code. So it comes with a rich tool chain to help you build, test, and debug your policies. Now, every time I come to KubeCon, I get really excited because as a maintainer, I get to hear about all these people that are using this project. And so, in fact, yesterday we held our first ever OPA summit, which was a great event. We had over 100 attendees, and we got to learn about how all these different companies are using OPA for a variety of different use cases. So we heard from folks at Pinterest about how they use OPA to secure their Kafka clusters. We heard that at Peak, their authorization platform built on top of OPA serviced something like 8.5 million authorization checks per second across the cluster.
Jesus.
We also learned from companies like Chef about how they use OPA not only to secure their APIs, but how they use it to control what components in their UIs are getting rendered. Right? And then later this week, you can hear from folks at Yelp about how they're using OPA and Envoy together to secure their microservice infrastructure. And then you'll later in that day also hear from Goldman Sachs about how they use OPA in Kubernetes for policy. So OPA gives you this building block that you can use to decouple decision-making from enforcement. And a lot of the time what this boils down to is plugging into extension mechanisms in these different kind of projects, right? So in Kubernetes, a lot of the time this is admission control. And in Envoy, it's called external authorization. And as projects mature, they tend to add in these kinds of extensibility mechanisms. Now, there's another piece of general purpose technology that's emerging that really that I think is going to have a huge impact on extensibility and on programmability in the cloud-native ecosystem. And that technology is called WebAssembly. So I don't have enough time to go into detail here, but in the last year or so, we've seen WebAssembly become adopted by all kinds of different products and companies and projects. So CDNs like Fastly and Cloudflare have given you the ability to run WebAssembly compiled workloads on their networks. Envoy has added WebAssembly-based filters to the proxy. You can even run custom database built-in functions in databases like Postgres. So I think that what we're seeing is basically an emergence of a standard execution environment for arbitrary code.
Oh, it's so long
I'm
overdue.
super excited to announce that in the latest release of OPA, you can actually take any OPA policy expressed in Rego, compile it into WebAssembly, and then run it in any of those runtimes.
Oh.
So that's the big announcement. If you're interested in
We need
WebAssembly or
standards.
policy or authorization, please reach out. And don't forget to check out the Styra booth after the keynotes. Thank you very much.
Having standardization of some level to have everybody developing against the same language or framework or whatever is going to make a huge difference.
So the next project I would like to highlight today is if you've ever looked at or smelled at Kubernetes, you've heard of this thing called etcd. And what I would like to highlight with etcd is it was a release that was maybe over a month ago where the team that actually works on etcd has been able to scale it up where they can have 5,000 node clusters. And coming from the world where, coming from the cloud world, 5,000 servers, that's not too many. But if you're actually thinking that these are 5,000 node Kubernetes clusters that are operating at scale, that's quite a feat. And if you've ever tried to install etcd from the beginning days, back when it was etcd1 and the transition to etcd2, you can see how far the project has come. So I definitely wanted to highlight etcd in our update today. And the final project that I would like to highlight, there's not a lot of words on here, and there's actually, there's a reason. We like to talk about software. How many of us are software developers? Who writes software for a living in here? Right. Notice that that was not everybody. There are people that contribute to our community through ways that aren't just software. And Cloud Events is actually one of these. What Cloud Events is a specification for sending events. And just on the surface, you're saying, well, why is that important? Well, the thing is, if I just started speaking Greek right now, there's 8,000 people in here, someone here probably speaks Greek. But if I went into a patois, or if I went into just gobbledygook, no one would be able to understand. So being able to understand a language and having a specification for that language is a great idea. So I have to commend the Cloud Events project for actually going through and doing the thing that all of us developers like to do the most, AKA documentation. So just wanted to give them a shout out just to say that the CNCF is more than just software. The CNCF is more than just picking winners. The CNCF is about is about cultivating an ecosystem that we can all work within. And I will go into this more on Thursday when I'm actually allowed to rant. But I will say that I love seeing projects like this succeed and have uptake. So with that, I would like to end our CNCF project update. And I think Vicky's going to come right back.
Thank you, Brian.
Thank you, Brian. Our next presenter is Erin Boyd. Erin is a principal software engineer at Red Hat. She's also a Kubernetes contributor, an active member to Kubernetes Storage SIG, and the co-chair of the CNCF Storage SIG. Today, Erin will discuss how the Rook project is extending storage capabilities to deliver your applications. Please welcome Erin Boyd.
Good morning. Is everyone still awake? Do we need more coffee? So, As Vicki said, my name is Erin Boyd, and I've been part of Kubernetes since our humble beginnings. I've spent most of my time contributing to the Kubernetes storage SIG, and now I'm the co-lead of the CNCF storage SIG. I currently work at Red Hat in the CTO office. What does coffee have to do with Kubernetes? Well, first of all, as programmers, it's well documented we love coffee. Studies have shown us that coffee makes us smarter and more productive. We love coffee so much we have named programming languages and open source projects after it. Legend has it that a goat farmer observed that his goats were more energetic after feasting on a coffee bean plant, so he set out to figure out how to get the same benefit. He must have been an engineer at heart. However, taking a bean from a plant and turning it into a cup of coffee is a process. So just like us, he had to first figure out how to get it working. Isn't that how all things start? Who can remember just holding their breath? Docker would stay up long enough to see their pod go to running instead of crash loop back off. As time goes by, we improve the system and the process to try to get it working consistently. But since we're engineers, just making a simple cup of coffee or getting a pod running is never enough. We must have foam and caramel and metrics and persistent storage. We always want to make it bigger and better. But this comes with a price. And as my graduate professor, Dr. Gatterdam, used to say, keep it simple, stupid.
Mm-hmm.
The operator framework makes it simple to create and deploy operators in any environment. Operators like Strimzi that simplifies running Apache Kafka cluster on Kubernetes, or Nuba that provides object data services for hybrid clouds, and KubeVirt that allows you to run a VM on Kubernetes to help facilitate migrating legacy applications onto this new platform. These operators
KubeVirt's on the
can be
list that we're going to play
compared
with
to the
soon.
single-button coffee technologies we have today that take a simple bean and create a lovely cappuccino with just the push of a button. But we all know how great operators are today. I want to focus on storage and the operators in Rook. Rook provides orchestration for several storage solutions, like MinIO and EdgeFS, as well as operators for stateful workloads like Cassandra and CockroachDB. Rook was created to address the complexity of deploying non-cloud storage on Kubernetes. Though storage in the cloud is easy to deploy, it's fundamentally disconnected from other non-homogeneous clusters. And once we consider enterprise concerns like regulation, data privacy, and cost, we may choose to move some or all of our data on-premise, or share between multiple clusters, or even hybrid clouds.
Or use
RookCef
NetApp services.
connects these non-homogeneous
Cloud
clusters.
volumes, Azure NetApp
By
files.
using RookCef, we create a universal backplane for storage for file, object, and block to have the same services across any environment. Think of RookCef as having your favorite cup of coffee at home taste the same if you have it at Starbucks or Pete's or Dunkin' Donuts. Having this consistent base gives us the same features across all of our clusters and clouds, including support for connecting and managing data in a multi-cluster environment. As my colleague Saad Ali outlined in his keynote at KubeCon Barcelona, we have been focused on these 4 steps in the storage SIG. But today we need to look forward to the next evolution, that is multi-cluster storage at scale, where having this universal backplane is imperative. And as engineers in the SIG, we all know that multi-cluster storage at scale is hard. Where the hard thing consists of migrating data seamlessly between clouds, snapshotting data to seed new application instances, backing up and restoring data and clusters, cloning and copying data between nodes and clouds efficiently, and creating a data policy that can automate all of this. All of these things have to be solved in the real world for hybrid cloud and multi-cluster to support scalable, persistent storage across the enterprise. RookCef is your single button automation to make your storage the same everywhere. RookCef is storage caffeinated. And storage is critical to hybrid cloud. Storage will enable the stateful workloads which are paramount to our success to support the cloud-native applications of the CNCF and workloads for all of our users. I truly believe we represent the people who are going to bring about the future of hybrid cloud, this community here today. But solving these hard problems involves more than just storage. So while you're here at KubeCon during the hallway track or the coffee track, Come find me, and we'll talk about how we solve this together. And since all great ideas come from coffee, let's keep Kubernetes caffeinated.
I guess. I mean, that's what it comes across as, C-Tech, is Rook Red Hat's version of Ceph. I'm not sure. I didn't really get a clear picture of what Rook is supposed to be there.
Our next presenter is Derek Collison.
It also, it's a little
Derek
concerning
is the
that
founder
a
and CEO
non-storage
of
company is leading the storage
He's
SIG.
also the creator of NATS and Cloud Foundry.
I don't know whether I should be that
Today,
upset about
Derek
that or
will
not.
give a brief history of the NATS project and where it's going in the future.
That's
Please
never
welcome
ended well
Derek
in the
Collison.
past.
Good morning, everyone. Hopefully everyone's having a great KubeCon so far. Some folks in the room might still debate whether or not we're in a cloud economy or if we've moved to a data economy. And an economy, at least from my perspective, is what drives value and innovation, right? So what are we extracting out of the systems? I would argue that we've actually transitioned into the connective economy, and that what's actually driving the value and the next wave of innovation is actually how we actually connect, observe, secure, and trust all of these distributed systems and services that we're building. The NATS.io project sits fairly in the connective economy. And so I'd like to give you a little bit of history, a little bit of where we are today, and of course, where we're headed. So NATS is a simple, production-proven, cloud-native messaging system.
Okay.
It does things like services and streams and different levels of quality of service, built from the ground up to be cloud-native. And it has over 30 different client language implementations, most of whom are from other people outside of the core maintainer group. This is a sample of some of the clients that we have. And we feel that the diversity of the clients, picking the language that you want to actually be able to access a system like NATS is really, really important. Here's a small sample of some of the NATS users. And we have some use cases that we wanted to walk through to kind of highlight how some of these companies are using NATS technology to drive that value that we were talking about in that connective economy. So what does NATS actually do? What can you use it for?
So is this another MQ
Some of the use cases are,
project?
of course, cloud messaging, both services and streams. And services, in our opinion, need to be scalable and transparent, resilient, self-healing. But again, services are that request reply.
So
right?
just like cloud events that
IoT
Brian
and
was touting earlier, here
Not
we
sure how
have
many
yet
people actually
another
think about IoT and edge, but when we think about it, we
yet
don't
another
necessarily
iteration
think
of an
about
events
maybe a small device
piece of software
that's out there.
trying to be the standard,
but we
I
think
guess.
about any type of hardware that a company might want to deploy out to the field, or a piece of software that's not in their direct total control. And of course,
That's
there's
gotta
the
get
notion of
standardized at some
augmenting and
point.
replacing
Somebody's gotta pick one.
legacy messaging systems.
Or I guess
of
the
which
community has
in my
to pick
past
one.
life, I was responsible for some of those. Some of the user testimonials we'll walk through very quickly, just kind of highlight how NATS can actually take effect within your organization and actually change the things that you're trying to do. Coria is a system that actually is an orchestration, clustered orchestration and secure system that can do 50,000 nodes right out of the box. And I've heard quotes of over 350,000 nodes in terms of query and command and control, all responding in about 700 milliseconds. Netlify utilizes NATS for a lot of their end services and supporting over 500,000 different customers and developers and businesses. MasterCard, leveraging NATS to transition from a legacy messaging system over to cloud-native systems for services and streams and things like that. And we've been working with MasterCard for over a year now, and it's been great to see how much feedback has come back and made the NATS project better, working really closely with some of these large organizations that kind of push and prod your technology in a different way that you might not have foreseen. So it's been an amazing relationship for us. Storage OS utilizes NATS as a control plane, right? Similar to how I used it very early on. So volume creation and deletion are events that are transported globally.
Why would you build this out
NATS
versus
to actually
AWS
keep everything
SQS? I don't know.
as things move along.
There's no standard. So there's going to be fanboyism
Tinder.
across the board.
Tinder
for,
actually used to have a
yeah, but I use
pull-based,
this one, and this is the
mechanism,
so that
and
means
they
it's
moved
the
to
best
total
one.
push-based mechanism for all of their services utilizing NATs. And one of the interesting things, and I don't know if this
I have heard
resonates
of
with
NATs. I
people
didn't
in
know
the
it was
crowd
another event/messaging
the folks from
product.
Tinder actually joined the Slack group. We had no idea who they were, and we were asking questions. And then after about 4 months, they popped in and said, "Oh, we're going to write a blog post." We just rewrote our whole back end, and a lot of times that just kind of happens that way.
For Tinder.
Platform 9 is a serverless functions as a service framework where they utilize NATs for their event sourcing and distributed coordination across their system. And they chose it because they felt NATs was very approachable. It's very, very simple, and it's reliable. And Click, who does data analytics, they use NATs to broadcast messages to facilitate data synchronization, work queue management, and cache invalidation, which we've heard a lot about as of late in the Slack channels. So now I want to talk a little bit about the NATS ecosystem. And for me, this is one of the most rewarding things that we do in terms of actually working with other developers, contributors, and then, of course, end users and customers who actually can extract that value right out of that connected economy. Some of the integrations in terms of the CNCF are a single line deploy into Kubernetes, which the team has done an amazing job with, and I'll show a little bit more here in a second, but I really encourage you to take a look at that. Prometheus, FluentD, Open Tracing, Jaeger. Someone from Microsoft just recently introduced us into Dapper.io as a component integration, which I think is amazing, and I really like the project, and I'm interested to see where it goes. Spring Boot and the Stream Binder, NATS Kafka bridging, NATS MQ series bridging, and of course, Go Cloud and Go Micro integrations. One of the things that I think is interesting, and this says NATS monitoring, maybe even think about it as NATS observability, both in terms of NATS itself and then what NATS is actually enabling. We put a lot of work into integrating and things like that, and I wanted to thank the community who pushed back on us and said, hey, you know, we want to be able to observe the applications that are running on NATS. And I take this on. I said, well, it's a pub subsystem. It's easy. You can see anything you want to do. And they really kind of pushed and said, but it's not as easy as it should be. And they were right. And so we did more work with Prometheus. We did more work with applications that are running on the system that we can do things like service latency, which we'll talk about in a second. So we can do things like global dashboards. NATS can run anywhere in the world, any deployment platform, any cloud provider, on-premise, doesn't matter. We support clusters, superclusters, and then extended superclusters, which I'll also talk about in a second.
Extended superclusters.
And here's that piece that the community pushed on us about, which is, hey, if we have an application and it's a service, you ask it a question, it gives you an answer back. NATS doesn't make it easy enough for us to figure out what's going on. And this could look kind of familiar, right? This is a lot of the functionality that we see in things like Jaeger and OpenTelemetry and even service mesh implementations. But within the NATS world, it wasn't as easy as it should have been. And so we really dug in, and we came up with this, which is totally transparent, no code changes whatsoever in any application, even ones that are 8 or 9 years old.
So for those of us that are infrastructure dinosaurs, is this like SNMP monitoring of everything that's going on across Kubernetes and all of your applications? Is this that equivalent of
supercluster being spent going
but
back
for
and
cloud
forth between
native?
nodes and NATS? And we present all 4 of those.
I can't get my head around what this actually
in
is.
real time, instantaneously, to any subject they want it to show up on. So how do you actually get started though with NATS? Well, I like to, when we engage with users and such on Slack, or if we actually go
maybe more like an extra hop. Okay.
We talk about the basic messaging patterns, services and streams. 90% of microservices, distributed systems architectures are in services, request to reply, but they need to be able to scale up, scale down. They should be location transparent, and they should be observable out of the box. And then, of course, there's streams, both, I think, real-time and the persistent versions. And you should be able to do playback by time, sequence, only last received, whatever you want. Once you have a basic message pattern and understand what NATS provides you, You can then go on and say, well,
How long
need
am I streaming today? Just the keynote, so it's supposed to go until about another half
In the older
hour.
days, it used to be a NAT server.
We'll
Now
see
it's a
how long
system,
it lasts.
Right?
And
so
then
we have free
tomorrow,
community servers
same
that have been
time,
running for over 3
Thursday,
years
same time,
that
9
people,
Pacific, noon Eastern.
Connect to and
hour and a half.
unfortunately, sometimes try
all
to
the
run production
keynotes.
stuff, and we say you probably don't
And
want
then
to do
Friday
that,
we'll
per
do the
se.
big stream for a couple hours.
This next one is
Cool.
the one
Thanks
that
for
I'm
stopping
so
by,
excited
Z-Tech.
about. Our
See you,
team has
bud.
put such an amazing amount of effort into a single line installer, which is the norm these days, right, for installing software into Kubernetes. But this sets up a 3-node, totally fault-tolerant, highly available, self-healing system with monitoring, Prometheus, and Grafana dashboard all in one. And so I really, really encourage you to come by the project booth and watch our team actually demonstrate that. Docker, and of course, there's additional information on our docs for how to get started and how to access these systems. So how do you actually build a service with NATs? Well, this is an HTTP versus NATs kind of what does it look like? How simple is it or how hard is it? And this, of course, is HTTP. It's written in Go, should look familiar to a lot of folks. And this is the NATs version. Form a connection, it's multiplexed, and you say request. Give me 2 seconds to get it back. Of course, you can do this asynchronously if you want as well. How about as the service, right? The server side, the endpoint. HTTP again. And here's NATs. Again, make a connection, do a queue subscriber, meaning I can transparently out of the box just run more of these or less of these, however I want to. We'll list it on bar, and it's V01. So it's really, really simple, even with existing applications, if you want to try it out, to do so. It's a couple hours in the morning type stuff. We've deployed full global systems in less than a day. It's really, really easy to get started. And the application, that application, never changes regardless of what the topology changes underneath with your cluster or supercluster. Now what's interesting is what we get for free. I think this crowd is used to an architectural pattern where we add sidecars and proxies and things like that, and I think that's great for most things.
Any cloud, any
Some things, though,
geo,
they should
any
feel like they
deployment
should be built
framework.
in. And with NATs, this has been since day one.
Okay.
NATs is almost 10 years
No
old now.
load balancers.
You can deploy to
No
any cloud,
DNS
geo
updates.
deployment framework,
No
on-premise,
config
cloud, or
changes.
IoT. You don't need any load balancers. You don't need any DNS updates. You don't need any config changes for scale up, scale down. And again, that point that I pointed out, you have
NATs
the ability
on the
to
list.
turn on transparent
We'll
service
look into
latency
it.
tracking on a global scale. A little bit about NATs history. Some folks might already know this, but NATs was originally created by me to power Cloud Foundry, which was a platform as a service that started at VMware, went to Pivotal, I think it's going back to VMware, and it's kind of the precursor to swinging back the pendulum to IIS and Kubernetes and things like that. I spent a decade on deployment mechanisms and systems like that. But it was for command and control, querying, telemetry, all those normal things that
Event
I
management.
would do when
Auditing.
building a distributed system.
Yeah.
One of the big things that I wanted NATs to do, though, is not do too much. I wanted to do just very, very simple patterns, request reply, streaming, distributed queuing. You know, I could do the load balancing thing, what we looked at there. But I wanted it to protect itself at all costs. And that's what I learned. It was an amazing lesson I learned when I was at Google, which is don't have one user take down the whole system, right? Gmail might be out for me, but it shouldn't be out for anyone else. And that's kind of really took that philosophy to heart. And cloud native hadn't been coined yet, but that's kind of how we moved into cloud native, which is it's protecting itself at all costs. It needs to be available all the time, regardless of what else is going on. So then it was built for me. You know, it's that scratch and itch thing that a lot of projects kind of start with. And I didn't care if anyone would use it or not use it. It didn't matter. I just wanted it to power Cloud Foundry and Bosch, which was the orchestration engine at the time, for the control planes and the telemetry system. And now, Cloud Foundry is very different looking today. I don't even know if it uses it anymore or not. I know Bosch does. But that's what it was used at the beginning. Fast forward almost 10 years now. Time goes by very quickly. This does not lack for ambition, but we really believe it's the enabling technology to securely connect all the world's digital systems, services, and devices. And I know that's ambitious, and I know that's, you know, a big vision, but that's kind of what we're really trying to do. And we believe we know how to get there. The biggest thing is engaging the ecosystem and having people kind of help us right along the way. And so you should be able to have a shared utility of any size. And hopefully this resonates with people, right? We have one of these, it's a silo. Now we have 2 of them, now we have 10 of them. Someone raises their hand and says, hey, why don't we put something together where we can all share one of these? And we probably all remember, have the scars on our back, that doesn't work very well a lot of times. Not a lot of software is built to not be a silo. So when you try to actually make it into a utility, it comes up with a lot of friction. It should be decentralized and federated, right? I should be able to have a shared utility and organization, and I should be able to run my own servers and stretch and configure things and do my own auth, but still be able to deal with
operation.
the actual shared utility system as well. Secure by default. We had about 15 years of the internet where we didn't have the green lock, right? We don't have that luxury anymore. We cannot go into IoT without understanding the security mechanisms. And so for us, 2 years ago, we went on this path. What did that mean is the system had to be federated, multiple people could be operating it, and no passwords or no keys were ever transmitted or stored to the system, ever. Again, on-premise, multi-cloud. You should be able to do communications, publish, consume, and save and restore state. Underneath the covers, it's just sending a message. I can send a message to KV set, and I can send a message to KV get. And a healthy and thriving ecosystem of services and streams that make building applications easier, right? You put them together like building blocks. Now the community, this again is amazing to me. I could have never foreseen any of this, and none of this would have happened without the community. We've got over 1,000 contributors, over 100 with more than 10 commits, 33 client languages. Most are from the outside community, outside contributions. Across all of our repos, about 15,000 GitHub stars. This one still is interesting to me, and it's accelerating at an amazing rate, which is 100 million NAT server downloads from Docker. You got about 1,600 Slack members, but again, it's accelerating. All the charts are going up and to the right.
100 million. Some of these numbers are crazy.
So we do about 5 a year. We just did one yesterday, as a matter of fact. So in the last 2.5 years, what have we been doing? Well, I talked a little bit about it. We designed a public key system utilizing all the cryptography standards. We didn't reinvent that part, but we utilized JWTs for auth-Z and auth-N. Again, no private keys ever in a NAT system with this. We actually doubled down on secure multi-tenant. NATS is truly multi-tenant, meaning it can be built as a utility where Coke and Pepsi or FedEx and UPS can actually utilize it. We put additional network topologies in, gateways to form superclusters, and then leaf nodes to say, ooh, you're running the supercluster. I want to actually run my own set of servers, do my own thing here, but I want to be able to communicate transparently with you as well. Dynamic response authorization. You're only allowed to respond to something that gets sent to you. So I send you a request, and I say, here's my reply address. Please send me something back. Transparent services latency that we talked about, and then docs. The team put a tremendous amount of time into the docs, and we should have done it way earlier. 90% of the time people are coming onto the site, they're always sitting on the docs.
He's
So
getting a
all the
lot of
project
time on the
managers out
keynote
there
stage here.
Who, I'm sure you already know this, but double down on documentation. We also have a technology that is moving into tech preview while we're at this conference called Jetstream. And it's a combination of understanding things from my past in the 90s to Stan, which was kind of our first version of streaming with NATs. And it's a next generation persistent messaging system. It's going to be built into every NAT server. So it's part of the core. It can do streams, message queues, the old style, and work queues, you know, kind of like Celery and things like that. And it can do push and pull. NATs traditionally has always been a push-based model, but it can do push and pull. Has file and memory back storage, scales horizontally, and it's NATS 2.0 native, which means that it's multi-tenant and secure by default as well. So what's next? Where are we trying to go? You saw the ambition, you saw the statement. We believe IoT and Edge is the next thing for us. But we also believe to get there, we need to meet people where they're at, which means we'll be adding native MQTT support, both 3.1, 5, and 5 SN, I believe. We'll also do WebSocket support for mobile and web. And then, earlier presenter talked about WebAssembly. I've been watching this now for about 2.5 years with a lot of anticipation that with the security system we put in NATS, with the ability that there's no keys in there, but you can digitally sign things, that WebAssembly is the perfect platform to say, I'm going to digitally sign this and allow this to work inside of the network on ingress on this subject or that subject, or egress. Or on Jetstream, even more importantly, I think, is I want to create an observable to get messages out of the stream. I want this WebAssembly to be responsible for which messages I'm supposed to get. And again, additional stateful services where NAS isn't just about communicating things, right? It's actually about storing and retrieving state. Any cloud, any geo, zero trust. So we've had an amazing almost 10 years now. I'm so proud of the team, so proud of the ecosystem that we've done, but I think this is just the beginning. I think our trajectory is starting to go up, and as we're starting to integrate and talk more with more of the CNCF projects and figure out what the users need from a technology like this in a cloud-native format and situation, we're super excited for where we're going to go in 2020.
So all of that basically to say,
we'll learn more. There's a deep dive
Pivotal
session
and
on
Cloud
Thursday.
Foundry was
We'll be at the project
crap,
booth all
so I
week.
had to
Please
build
come ask us any
NATS.
questions. We'd love to chat with you.
I think
All
that's
of
what I
the-
heard
or
him
the
say.
majority of the core maintainers are here, and they will be there. The NATS website, obviously, the Slack channel, of course, email always works as well. Thank you so much. I really appreciate the time and the attention. Come join us, and let's connect everything. Thank you.
All right. Who's going to land the plane? Final 15 minutes. Did they pay for the licensing for all this music?
Thank you, Derek.
Good
Our
job,
next
guys.
presenter is Lachlan Evenson. Lachlan is the principal program manager on the
I hope I don't get
container
muted on
compute
Twitch
team
for
at
the
Azure.
music playing
He also serves
that
as
I don't have
the
royalties
Cloud Native
for, or
ambassador
licenses for.
and TOC contributor, and has deep
We'll
operational
see.
knowledge of many cloud native projects. Please welcome Lackey.
He just smiled and gave me a Vegemite sandwich. And he said,
Yeah, the audio's going to get muted on the VOD. Thanks, KubeCon.
G'day. How's everyone doing?
G'day.
Woo? Can I get a woo? I need a little energy. Come on. Okay, now I'll talk about something serious. Okay, thank you. Confidentiality for your data and code is critical in computing. In the ephemeral world of container orchestration, we need to pay attention to protecting data. It's hard enough to ensure data confidentiality at rest and in flight. And up until this point, it's almost impossible to make sure that your data has been protected during processing. In the wider cloud ecosystem, application security considerations include consequences of unauthorized data access, data leaks, establishing trust in infrastructure, and the need for regulatory compliance. Given this, we need hardware-level data protection where sensitive data can be processed confidentially and verifiably with guarantees. Security requires us to focus on every layer of abstraction, on hardening the application, the VM's operating system, the hypervisor, and host kernel. Great projects such as gvisor and Firecracker handle security for sensitive workloads at those layers. But what is often overlooked is the hardware beneath. When you opt into confidential computing for a specific application, you can access the hardware directly, taking advantage of hardware encryption in a trusted execution environment. We're already protecting data at rest and in transit. We can now offer hardware-level confidentiality and integrity while data processing. Microsoft is happy to announce an advancement towards confidential computing in Kubernetes. We are enabling containers running on Kubernetes to create and use trusted execution environments by means of the Open Enclave SDK, which allows you to verifiably guarantee that your data and code are isolated by the hardware itself. With encryption down to the chip,
is
you now
this reserved? I have so many
improved control
questions.
for ensuring sensitive data remains confidential. Scenarios ranging from line of business workloads, such as payment processing, and novel workloads such as multi-party machine learning for medical research. Organizations who have hesitated to move their mission-critical workloads can now run them with confidence. And this enables new use cases that may have been operationally prohibitive in the past, such as financial services, pooling their data together and using machine learning for fraud detection. Securing data is a hard problem. Thankfully, we're working to solve this across the industry. The Confidential Computing Consortium is a community project under the Linux Foundation, and it has a charter of accelerating the adoption of confidential computing. They launched with projects such as the Intel Software Guard Extensions SDK, the SGX SDK, and the Open Enclave SDK. Hey, but we're all here for KubeCon, so it wouldn't be fair if I didn't show some YAML. I think I'm the first one to show some YAML today. But here's how easy, yeah, thank you. I'm happy to oblige. Here's how easy it is to use confidential computing in Kubernetes with the Open Enclave SGX device plugin. This device plugin determines the allocatable resources per node. And as we can see here, we have a node that has 82 megabytes of encrypted memory. We can then define in our pod spec how much encrypted memory can be used for our application. Kubernetes will then schedule the app to a node with the capability and the availability. From there, your app can create and use a trusted execution environment. So we can see that this app has requested a limit of 64 megabytes of encrypted memory. That's all there is to it. So if you're excited to learn more about confidential computing, you can try it out for yourself on Azure today and come chat with us at the booth to learn more about confidential computing and other open source projects. Cheers.
I have so many questions. Is that using the reserved instances? Like, how do you get directly to the hardware? Does it just deploy a VM that is tagged to be run on hardware that can run encrypted memory?
And thank you to
I just
all
wanna
our
know.
keynote speakers for kicking us off this morning. As we prepare to go into sessions, I want you to think about how our ecosystem has matured. This morning, we can see how our projects have advanced and continue to break ground. This evening's keynotes will continue to showcase this piece of our ecosystems throughout our maturing, and we'll continue to touch on this overarching theme throughout the event. Now, a few housekeeping items before we break. First and foremost, don't forget to take care of yourself. We understand that this large of an event can be overwhelming and have created the Keep Cloud Native Well initiative. This includes daily group fun runs, a quiet room, massage chairs, chair yoga, and even therapy dogs, which I'm super excited about. Information for all of this can be found in the schedule within the wellness track. Next, as Aaron said, coffee is super important. Coffee breaks will be provided in the sponsor showcase, and lunch will be provided in Hall C in the West Terrace and 20 foyer on the upper level of the venue each day. See the schedule for exact times if you need to. And if you need to check your luggage or coat at any point in time during the event, bag and coat check is located in the Hall C foyer until the event concludes. To reference the schedule easily, go to kccncna19.sketch.com on your mobile device and add it to your home screen. After each session you attend today, we would appreciate you leaving feedback, which can be found at the bottom of the sessions page after you've logged in. Lastly, there are a few folks we need to thank because without them, none of this would be possible. Our diamond sponsors, Cisco, Google Cloud, Intel, Microsoft Azure, Red Hat, and VMware. Our platinum sponsors, the gold sponsors, and our diversity scholarship sponsors, whom combined provided $177,500 in scholarship funding, allowing for 115 scholarship recipients.
Wow.
Yeah. And last but certainly not least, if you were one of the 84 members of the program committee to San Francisco, or for San Diego, please stand up. They volunteered their time to review over 1,800 proposals for this event. So let's give them another round of applause. Join us back here at 5:20 p.m. tonight for more keynotes. Immediately after the afternoon keynotes, please join us at the Taco Tuesday welcome reception and sponsor booth crawl. There will now be a coffee break in the sponsor showcase, which is on the upper level in the sales pavilion and ballroom 6AB. Sessions will begin at 10:55 a.m. Thank you.
All right, guys, there we have it. There we have it. Day one of KubeCon 2019 US. Oh my goodness, that's loud. But I like their music, so we'll leave that up there. And we'll kick things over to this. Why is that out of whack? A little weird. All right, fix that. Anywho, lots to discuss. Already conversations happening in Slack about some of the things that were announced today. Lots going on. Really want to learn more about what Microsoft doing is around that confidential computing. I want to understand why NATS exists if it was just a deficiency in Pivotal and Cloud Foundry from 8-9 years ago. What was the other one? Vitess, the scalable database from what was it? Planet something. Sugu. Definitely going to look into Vitess. I had not heard about that one. But even if it's like a meta manager of multiple MySQL databases or the ability to just spin them up on demand, that's kind of cool. Or just replace them entirely. It sounded like it could do both. So we need to look into that one. We'll put that one on the list for Friday. Yeah. Well, just if you're watching, make sure you're back tomorrow. Same bat time, same bat channel. We'll be doing they're going to have another session from 9 a.m. Pacific. First thing at the show, day 2, for about another hour and a half. More content like this. And, of course, we're going to be right here live streaming it. Same thing on Thursday, 9 a.m. Pacific, noon Eastern. We'll be live streaming it as well. And then Friday, we'll do our big stream that we normally do right here on the channel. We'll recap a bunch of stuff that we saw throughout the week and look at some of the projects specifically. Go to their GitHubs, go to their project pages, maybe pull one down and look at it, tinker with Vitess a little bit if we can. But yeah, make sure you hit that little heart up above. You're following the channel. Hope you guys enjoy this kind of content. We're having a blast doing it and just trying to grow things out here from an enterprise perspective. There's a lot of code writing that happens on Twitch, but I want to do some more talking head commentary about enterprise tech and what's going on in the industry outside of that level. So I hope you guys are enjoying this kind of stuff. We are going to get back to our regularly scheduled program this Friday with our cloud build out as well. So keep that in mind. Thanks everybody for all the love from Tech Field Day. You guys rock, and we will see you guys tomorrow, 9 a.m. Pacific, noon Eastern, for the Day 2 keynote. Thanks, guys. Peace out.